Okay, in this video I'll try to show you how to graph sine or cosine functions with phase shifts. So we have a sine function y equals to 3 sine 2x minus pi over 3 plus 4. This can also be written as y equals to 3 sine factor out the 2. This becomes x minus, you're just thinking 2 times what is pi over 3, so x minus pi over 6, because if you multiply 2 with pi over 6 you get 2 pi over 6, and that simplifies to pi over 3 plus 4. Okay, from here we know that if we have the form f at x equals to a sine or cos k x minus d plus c, here we know that a is 3, k is 2, d is pi over 6, c is 4, and really we should show that it's plus 4. So what do these mean? Well, this one's going to give you a vertical stretch by a factor of 3, and this is really what it really means is that in a normal sine graph it'll go from 1 to -1, and that's 0 right there. In this graph it'll go from 3 to -3 with 0. K equals to 2, that's to tell you it's a horizontal compression. So if the graph was like I don't know, something like that, now the graph will be like that. I'm just illustrating. D will be shifted pi over 6 units to the right, and C is obviously going up 4. Okay, let's get some stuff from this. We know that the amplitude is 3. The maximum value, which you can say, well, let's just call it max. Max is, okay, so you have a graph with amplitude 3. So it goes like that, right? So it's at 3. And then you have C is plus 4. You're adding 4 to the vertical. So it goes up plus 4. 4 plus 3 is 7. So max would be 7. Min here was 3, or -3. Again, adding plus 4, -3 plus 4 is 1. So the minimum is 1. What else can we find? The midline. Midline is halfway between that, or it's 4. It's just the value of C. But you can do it as in 7 plus 1 divided by 2. Take the average, which is 8 divided by 2, which is 4. Okay. Now let's think about this graph for a second. Let me just erase this. Okay. So say we had something like that. Actually, let me use this. Something like that, right? So if you had a normal sine graph, it would start at 0, go to 1, and then -1, 1. It would have a period of 2 pi. Well, what's the period of this? We know that the period is 2 pi over k, and this would give us 2 pi over, what is k? 2. 2 is cancel out. Period is pi. So for this graph, we know that it'll go, if this phase shift was not here, it would go from it'll go from 0 to pi, and you just divide that by 4, and then you'd get your 4 critical points. Okay, for this one, however, it's being shifted to the right pi over 6 units. So it's simple. All you do is, instead of 0, it's pi over 6. Instead of pi, it's pi over 6 plus pi. So you find the common denominators, and it becomes 7 pi over 6. Now halfway between that, well, you could do 7 pi over 6 plus pi, just pi over 6 gives you 8 pi over 6. Half of that is 2 pi over 3. Half of this, or you could have added those two and just divided it by 4 and get what it is for each one, but I will just do that. I'm not here to teach fractions. Half of this is 5 pi over 12, and then this one would be 11 pi over 12. Okay, so what does this mean? Well, your graph, since it's a sine graph, it'll start kind of at the origin, if you think about it. So let me draw the graph now. Let me get a bit more space. Okay, so we have y equals to 3 sine x minus pi over 6, was it? Plus 4, okay. So you have the x and y points, right? And oftentimes it's best if you just make every point pi over 12, because then you wouldn't need to worry about getting a common x-axis value that would have all 4 of these in it. So I feel like I'm missing something there. 1, 2, 3. Yeah, no, we're fine. So if each was 5 pi or pi over 12, then we'd have pi over 12, 2 pi over 12, which is pi over 6. So let's say it was pi over 6. 3 pi over 12, 4 pi, 3 pi, 4 pi over 12, 5 pi over 12, 6 pi over 12, which is pi over 2, 7 pi over 12, 8 pi over 12, oh, I should be writing this down, 6, 7, 8, 8 pi over 12 would be 2 pi over 3, which is, yeah, it's one of our points. So you just see that it's going 1, 2, 3, okay, 1, 2, 3, so the next 1, 2, 3 would be, what was it, 11 pi over 12, I think it was, I'll check, and then 1, 2, 3, it would be 7 pi over 6, I think that's what it was, 11 and 7 over 6, yeah. Okay, now let's mark the y-axis. So we had a max at 7. Let's just say that right there is 7. Min at 1. Let's say that one's 1. And halfway between that, say that's 4. Probably not. This is an estimate, but hey, I just want to show you, I just want to get my point across. Okay, that's a fat line. That's cool. Ah, crap. That's annoying. Alright, let me see if I could. Okay, whatever. You get the point. I'm just marking where our max, min, and mid points are. Let me use red for the graph. Okay. So we know that if it was just sine x, it would start from here, go up to 1, come down, etc., etc. Now this graph we have here has been moved pi over 6 units to the right. So the d value here is pi over 6, right? So our graph would actually now start here, and then it's just the same thing as before. You might be wondering, well, we have a 3, so don't we need to multiply, divide, whatever? No, we already took into account for that when we did the max, min, all that stuff. So now you just have to plot the sine points. So for sine, it goes from the origin, and assume this is the origin, right? Because if this was just a normal sine x graph, this would be 0, 1, and -1. Origin, up, so let me line that up somewhere over there, and then back down here, and then over here, and over there. Okay, and this is going to be 1. That's going to be crap. Okay, yeah, good enough. And that's 1 period. So this right here is 1 period, because none of it is repeating. You have, it goes up, comes down, and it goes up back to where it started from. It does not repeat, so that's just 1 period right there. And boom, there you have it. You have the graph for y equals to 3 sine Okay, yeah, that's all there is to it. It's really not that hard. If you wanted to graph the cosine of this, let's see what would change. Amplitude wouldn't change. These odds, this would all stay the same. Stay the same. Period would not change either. Everything would stay the same. So would these, but all you'd have to do is start. So let me actually do the. Let me do it in blue. So be here, then here, here. Right? Because for the cosine, if this was just y equals to cos x, this would be 0, 1, and -1. And for cosine, it starts at 1. So this would just look like this. That's so bad. Well, you get the idea. It looks something like this, right? And obviously it's coming in from this way and going out that way, repeating forever. But from just here to there, that's 1 period, right? This is 1 period of cos. That's it. It's really that simple. Phase shifts are not that hard, and you can practice this with any other graphs, and they would basically all be the same. Just need to know that this part right here is very important, because here is really where you're determining how you're going to set up the x-axis, where it would start from, where it would end, and this is just talking about 1 period of either graph. But yeah, that's simple. Alright, hope you found it helpful. See you later.